So we are going to be explaining the homework right here on WSPM 5.6. And I like this worksheet because it has a lot of those special cases. Let's first start with this matching portion. To be able to graph any inequality, you want to first make sure it's in slope-intercept form. That's where y is by itself, and you have y and you have mx plus b on the other side. So what's the first thing that I need to do on this question 1? What do I need to do? I need to add 2x plus 2x, right? To get rid of the minus 2x, to get the y by itself, I want to do the opposite. Negative 2x plus 2x is 0. It disappears. What I do to one side, I must do to the other side. Now, I can't really add 2 plus 2x. Those are different things. It's like saying I have 2 apples, I want to add $2. Right? So you just rewrite it, okay? And of course, since we want y equals mx plus b, we're going to write the x term first and the b term second. So let's rewrite it. It's going to be y is less than the x term first and the number that's by itself second. And this is our slope-intercept form inequality. Why is it called slope-intercept form? Because you could clearly see the b value right here, which is positive 2. And you could also clearly see the slope value right here, which is 2, but you want it as a fraction, so you're going to put it 2 over 1. Okay? So if we go to the graphs that are given to us, or how about this, not even go to the graph. If I just think about this and make a quick sketch, if I make a quick sketch, I'll be able to identify it on the xy plane that's given to us right next to this. So where does it cross the y-axis? At 2. So I want to put a dot right at 2 on the y. And now from that point, what do? I go 2 up and 1 to the right. So if I do go 2 up and 1 to the right, I end up right here. And this is going to be a solid line or a dotted line? Dotted. Why is it dotted? Because there's no solid line underneath, right? So this is going to be a dotted line. So you put some dots. So as you can see, it's pretty steep going up. And now we need to shade in where the answers are at. So they're either going to be on the upper left side of this red dotted line or on the lower right side of this red dotted line. And we could test the point 0, 0 because it's clearly down here, right? 0, 0 is clearly down here on this side of the red dotted line. So if I test 0, 0 and it works, then I shade in this side because all of the coordinates on this side are going to work. If it doesn't work, then you have to shade in the other side. So it's as easy as plugging in a 0 for y and a 0 for x and seeing if it's a true statement. So if I do plug in a 0 for y and a 0 for x, 2 times 0 is 0, you could just scratch it out, and then plus 2 at the very end, it will say 0 is less than 2. Is that a true statement or false statement? True. So I know that this does work because it's a true statement. It is a solution. That means that all my solutions are on that side of the origin, or on that side of the line where the origin's at. Anyhow, you didn't have to do all that. This is a matching portion. And if you look at your possible answers, obviously it is option B. Now, some people get weirded out because they say, okay, the B value's at 2, and for some reason they look at it backwards. But that's not correct. From this point 2, you go up 2 over 1, and you do end up at that point. So you do end up with this line right here. And it is dotted. You do shade in the bottom. So this is the correct one for A. I'm not going to do all of these, but I do want to try number 2, because number 2, it's already in slope-intercept form, but what is my b value? It's 0. There is no b value, right? So what we could do is put a plus 0 right there, just to remind us that the intercept, the b value, is at 0. And from that point, I need to look at my slope. And what's my slope? Negative 3 over 1, right? So with the b of 0 and the slope of negative 3 over 1, I should be able to graph it. So if we look at our multiple choice answers, which one crosses at 0? D is the only one that crosses at 0, right? But you know what? Just for the sake of really understanding it, since we already know the answer is D because that's the only line that crosses at 0, I want to still get you to understand this even better. So let's pretend you didn't have multiple choice. Let's pretend you were actually graphing it right here. So you know it crosses at 0, and you know you're going to go from this point, you're going to go down 1, 2, 3, and over 1. And you know it's a it's a solid line going down 3 over 1. So this is what the graph looks like, and it's going right through the origin. Sorry about that. So if you want to shade in one side or the other, you need to test a point, right? And on the instructions from yesterday, I say test the point 0, 0. But right here, if you test the point 0, 0, it's not going to help you because the line goes right through 0, 0. So remember, the whole point of testing is to see which side your answers are on. So 0, 0 would not be a good point to test because it's right on the line. In other words, you need a point somewhere on this side or a point somewhere on this side. 1, 2 would work. 1, 2 is up here. Or 2, 3, right? Or maybe even 4, 0. That'll work. And how about that? Yeah, let's go with the 4, 0. Let's say this coordinate 4, 0. 4 on the x, 0 on the y. If I were to plug in 4 for x, that'd be putting a 4 right here and be multiplying it by -3. And it's going to be greater than or equal to y, but y is 0. So that would be that'd be a false statement, because what this would say is that 0 is less than or equal to -12. And that's false. 0 is not less than a negative number, it's greater than any negative number. So this point right here did not work, so where would the coordinates work? On the other side of the line. So you'd have to shade in this side of the line.
But how do you know that solid's going to work? Like, for every single one of them?
How do I know? The inequality is talking about an area, and the area is on one side of the line or the other side of the line. So if you want, we could actually verify any coordinate over here where the blue shading is at. Any coordinate over here will work. Any coordinate on this side will not work. Look, watch. Give me any point you want. -2 and 1. Okay. So if I were to put a dot right here, let's say at -2, 1, I already know it's going to work. Why? Because it's in the shaded area, right? Check it out. Let's plug in a -2 for x and a 1 for y. So instead of y, I want to have a 1 right there. Less than or equal to -3 times the x value of -2. And that really does become 1 is less than or equal to +6. And that's a true statement. So it's good that you brought that up. Any point right here in the shaded area will work. So that's why we graph, to represent all of our answers. Okay, so why do we shade? To show that all of our answers are on this side of this red line. And over here it's not shaded because any point you pick over here is not going to work. It's not going to be a true statement. Let's move on. Jumping to number 5. That one's very interesting because it's so easy that some students get confused, right? You could look at this as y equals mx plus b, or you could look at it as an equation with the input-output values, such as an xy table, and make sure that all your y values are -1. Let's look at it as y equals mx plus b. So y is less than, what's our value in front of x? What's the m value? The number in front of x. Now at this point you're supposed to be thinking, wait, there is no x. Exactly, there is no x. How do you represent no x? 0 x's. 0 times x means that there is no x, right? And then +1. I mean, not +1, -1 at the very end. So this inequality here is really the same thing as that. But right here we're showing that there is no slope, that the slope is 0 because there is no x value. Are you with me? So in terms of y equals mx plus b, in slope-intercept form, where does this cross the y-axis? -1. So let's put a dot at -1. Now we know that the line crosses through this point. It might cross really steep going down. It might cross really steep going up, or maybe just kind of steep going up. It all depends on your steepness, which is your slope. What is our slope in this case? 0. What does that look like, 0 slope? That's saying that it's not steep. Give me an example of something that's not steep. The floor, right? The floor is not steep at all. It's totally flat, right? So that has a slope of 0, okay? So what kind of slope do I have here? It's no slope. So let me draw a line that has no steepness, that's totally flat. Now, of course, we could also go back to, oh, wait a minute, I'm sorry. This is not supposed to be a solid line, right?
No,
it's supposed to be a dotted line because the inequality doesn't have a solid line underneath it. So let me go back and erase a couple of spots right there. Okay. Now, another way of looking at it would be to think of the equation y equals -1. You guys remember that equation? If you thought about an xy table, oh, that crosses, or that has the coordinates y values having -1, and the x values could be anything you want, like -2, 3, 1, whatever you want. And if you did go to the coordinate -2, -1, you'd go -2, -1, you put a dot right there. If you went to the coordinate 3, -1, 1, 2, 3, -1, put a dot right there. If you go to the coordinate 1, -1, 1, -1, put a dot there, you will see that it's the same flat line that we have right there. Anyways, that's graphing it. And like I said, you don't have to use an XY table. You could think of it in slope-intercept form. Crosses at -1, it has no slope. And in addition to graphing the dotted line, we also need a shade. So how do we shade? We need to test a point. What's the easiest point to test? 0, 0. So if I wanted to test the origin, 0, 0, 0 for x, 0 for y, I need to plug in 0 for x. Now look at the equation. Where's x at? There is no x, right? So who cares? You don't need to plug in 0 for x because there is no x. But you could take the y of 0 and plug it in right here. So if I plug in 0, 0 into the original equation, it's going to say 0 is less than -1. And that is false. So yeah, you're right. This is not an answer, so we have to shade in the bottom part of this dotted line. You see, no coordinate up here is going to work. All coordinates down here are going to work. So even if I said, does a coordinate 50, -10, does that work? 50, -10? Yes, 50, -10. If you go 50 way out here and then -10, it will be in the shaded area, so it's going to work. Anything above is not going to work. Oh, here's another one with the y-intercept of 0. Let's do that one. So this guy has the b value of 0. You could put the +0 if you want. That's your b value. Your slope value is 3, but you want it as a fraction. Put it 3 over 1. So let's graph this thing. Where does it cross the y-axis? 0. What do I do from that point? Up 3, right 1. Up 1, 2, 3, over 1. There it is. Now if you want to extend it all the way through, which you should, you probably want to use the same pattern of up 3 over 1, but backwards. Over 1, down 3, over 1, down 1, 2, 3, and put a dot right here. And now, is this line going to be solid or dotted?
Solid.
Dotted. Because there is no solid line underneath it, it's not going to be a solid line. It has to be dotted. Dotted line coming up. And now let's shade. I either shade in this side over here or the other side. So I either shade in this side up here or this side, depending on where my answers are at. Right here, I cannot use 0, 0. 0, 0 won't cut it because 0, 0 is right on the line. So I need to pick something else. 1, 1's good. I like to use 0 though, right? Give me something with 0. 0, 1? Okay, so 0, 1, where's 0, 1 at? It's right here. That's not on the line, right? That's a little bit above and on the left side. It's really close to it, but still, it's not on the line. So we could use the coordinate 0, 1, plug in 0 for x and 1 for y. Let's actually do that with the original. Plug a 0 for x and a 1 for y. That will say 1 for y, 3 times 0 for x. 1 is greater than 0. Is that true? Yes, it is. So this point does work. That means that all the points up here work. All the points on this side of the line work. So let's shade in that side of the line. You see, it's easy. Of course, you need to rewrite it in slope-intercept form first. Oh, how do you do 13? I'm so scared. Decimals. What? How do we do 13? And just the same? Okay. So we could deal with decimals, or if you're totally afraid, you could convert them to fractions and then get rid of the fraction. You could change the 0.5 to 1/2, because 0.5 is half, right? You can change this to a negative half, right? Or you could actually just add 0.5 and add 0.5, you end up with a 1.5 as b. Whatever you want. So what do you guys want to do? Convert them to fractions? Leave them? Okay. So if I were to convert them to fractions, I'm going to end up with y minus 1/2 is less than negative half x plus 1. Yay? Now let's say you want to get rid of fractions. Okay, which you don't have to, by the way. But let's say you wanted to get rid of fractions. What could you do? Multiply everything by what?
2.
By 2, by 2, by 2, by 2. So you will end up with the new equation or inequality that says 2y. This one cancels out right here, so you have a minus 1. This cancels out. You're going to have a minus, or less than minus 1x. And then at the very end, 1 times 2 is 2.
That's, you just put it in 1. You could just done it and crossed it out at the beginning with the decimal.
Could have. So let's continue getting rid of the minus 1 by going plus 1. Plus 1. I have a new equation that says 2y is less than negative 1x plus 3. Final step is to divide by 2, divide by 2, divide by 2. Y is less than negative 1/2 x plus 3/2, which is really 1 1/2. Yeah, this was not that fun. We should have just dealt with the decimals. Anyhow, let's deal with this. It's already in slope-intercept form. Let's graph it now. Where does it cross the y-axis? 1 1/2. So that's 1 and then halfway up right here. Strange, it's right in the middle. Let's put it there. 1 1/2 right there.
Would it have been the same if you would have done it like with just the decimals?
With the decimals, if we would have gone with the original and stuck with the decimals, check it out. You would have added 0.5, right? And you'd have to add 0.5 to the b value of the 1. So what is half plus 1? It's 1 1/2 or 1.5. Either way, you're going to have to go up 1.5 halfway up. So yeah, this was kind of a waste of time. We could have just dealt with the decimals. Anyway, we know that it's 1.5. That's where it crosses. Now from that point, what do I need to do? This is the tricky part. What do I need to do? Down 1 unit, that is, right? So from this halfway point
So it'd be the other half.
to the other halfway point. That's right. That's down 1 unit. From here to here is down 1 unit. And then I run 2 to the right. 1, 2. So this is my next point. Let's put a dot right there. And of course, if I were to go backwards, it's kind of like going 2 this way and up 1 unit. 2 this way and up 1 unit to this halfway point. And we could continue to go 2 this way and up 1 unit to this halfway point to make the line go all the way through the whole graph. And same thing with the other direction to this halfway point. And now, is this going to be a solid line or a dotted line? Dotted. So let's put a bunch of dots or dashes, whatever you want to put. Arrow here, arrow there. Now we need a shade. Let's test the point 0, 0. And we could go with the original or we could go with the modified one. Let's go with the original. If I were to plug in a 0 right here and a 0 over here, so 0 here is going to make it disappear. I'm just going to have a negative 0.5 being less than, right here, negative 0.5 times 0 is 0, plus 1 is 1. So is negative half less than 1? Yes, it is. So it does work, right? So the origin does work. The origin is a solution. That's a yes. That's a happy face. So all of these are answers, so you shade in this bottom side. And that's it. I'm going to give you the rest of the period to work on the rest of this worksheet. We are going to do 1 through 13. You want to do all of them. And this will be the first part of our test next week.